at the teaser talk, I mentioned to you this is a project like my team worked on with the product team that was launched in product about 2 years ago, and it's right now affecting about 1% of the Google search traffic, which is pretty significant if you worked at Google a little bit. So the idea was actually, as you always, as most of people know, like Google search and not just Google search, Bing search and everything is moving towards beyond the 10 blue links, and we want to make the search result page more richer and more interesting for our users. And this is part of that effort. And actually, KP is the starting of that. And from within KP, we're also exploring more engaging facts, like those interesting tidbits about some entities you're looking for. So this is actually a project that the product team reached out to us because they were doing this so-called fun facts project, and they were generating fun facts that are somewhat interesting, but not really engaging, and they have not enough coverage for the feature they are looking for. So they come to us and they say, hey, can you guys come up with some ideas? So we said, wow, this is actually interesting. We might be able to do something for you. So what is the problem? Oh, well, this is really challenging. All right, so what is the problem? The problem is basically we have entities where we are trying to identify. So we have entities where we are trying to identify how users can be engaging with them in terms of providing interesting tidbits about the entities in question. So there are basically several things we're looking at, and I'm still looking at the summary slides from the previous speaker, so this is a little bit distracting. So let me do this. Yeah, I'll try. So there are several views we are looking at for this particular interesting fun facts generation problem. So the first one is what we call a single view, which is identify what is the most interesting about this particular entity. And then we also have a so-called categorical view of, so the first example, like Frozen is the highest grossing animated film of all time. That's the single view, single top K view. And the other one is similar to that, but we try to put that into the context. For example, Shanghai Tower, it may not be the tallest building throughout the world, but it is the tallest building in China. So we are trying to identify that as well. And the last one is the most interesting, which is essentially the idea of so-called distributional view. The idea is like you are interesting because you're part of the group that is very interesting, right? So here the case is like 4 of the world's top 10 best-selling fiction authors are British, and including Rowling, who wrote the Harry Potter books, right? So this is another interesting aspect of that. So the challenges, of course, are threefold. So 2 of them are actually very consistent with the previous talks as well in terms of the interestingness. You have to define that. And then you have to, so-called reliability in this particular case is like it has to be self-contained, and it's an interesting fact that on its own can stand for them because we're putting it in the knowledge panel. And then there's also data refreshness, because the data source we are digesting from across the web, and the web changes all the time, and we have to make sure like there's not much incremental work that we have to do in order to maintain the system. So, all right. So there's a bunch of related works there, and as I say, many of the related works are coming from the database and semantic web field. It's actually quite interesting. A lot of people actually look at this problem before. And our solution turns out to be a cross between database, semantic web, as well as a lot of natural language processing, as you will see. So we did a comparison with all of these in realistic user studies that is required for the product launch. All right, so let me see if I can explain this in a way that I can at the same time see it. So the solution we come up with is actually strength of the group. Our group have been working with tables on the web for a long time. So one of the things we look at, okay, so this problem, even though the problem is specified as like looking for interesting things about the entities, turns out there's a lot of interesting tables on the web that are talking about those entities. And so if you pivot things away from entity-centric to be becoming table-centric, you can actually generate a lot of very interesting things about entities from those places. So the idea is like we're looking at so-called superlative tables on the web, and identify those tables and then pick up those entities and translate those rows in those superlative tables into the interesting sentences that you see in the KP. So this turns out to be working really well. Here is the highest grossing animated film. This is the Frozen example, and that gets matched to, in the simplest case, gets matched to the Did You Know example. All right. So next one. Oh, wait, so this is your clicker, right? Oh, okay. So I can actually use that. So let me see if I can here. Might be better. All right, so this is actually a little bit better. I don't know if I can take the mic off. Oh, all right, actually works. Okay, all right. I wonder what I spent 5 minutes for. So, overview of the architecture. So, I think I'm going to go a little bit quicker on this. There are basically two major parts of the architecture. The first one is called a template generation. Basically, is how we take the table and generate those interesting templates that you see in terms of the sentences. And the second one is called a dynamic maintenance, which is essentially once the templates are there, the templates are actually pretty expensive to generate, as well I will show you. And it's also a machine learning algorithm that doesn't have 100% of the precision. So you want to make sure like you leverage all the templates and ML generated as well as human generated templates as much as you can. So the idea to do that is you track all those tables and making sure from snapshot to snapshot you identify the right table along the way so you can reapply this without human intervention. So template generation. So this is somewhat a busy slide, so bear with me a little bit. And so how am I doing on time? Good, all right. So basically on the right, you have this so-called web table, and this in particular, this one is coming from superlative tallest buildings in the world from Wikipedia. In our prior work in the group, we actually did a lot of work in terms of identifying what is the subject column, in this case are the building names, and what are the metrics, what are the categorical columns, and all these things. That's our prior work. All right, so our current work is essentially, as I mentioned to you, the top K view, simple view, and the selective view. We want to basically identify those sentences, components of those sentences from the table itself, all right? So as you can see, the entities are pretty easy. If you understand what is the subject column, you can easily identify the entity. Ranking the entity is also easier. You basically look at how popular those entities are, which ones are interesting to you, right? So this one is actually quite interesting. So sometimes it can be generated from the superlative ranking itself. The first row, second row, the second one is second tallest, and third one is third tallest. Otherwise, sometimes you have to rearrange the table based on the metric you are interested in. So this is actually very interesting work. Tallest, it goes beyond. So tallest is actually the natural language component of our work. So basically, to learn that in this particular sentence, you need to use tallest. There are two ways. One is you can extract from the title, and the title, sometimes the title works, sometimes it doesn't work. And if the title doesn't work, then you have to figure out from the column name, say height. So you should be able to identify, hey, from a machine learning perspective, using a number of embedding technologies to say basically, okay, if it's height and ranked according to height, it's either tallest or highest, and depending on the context, right? So this is the component you have to learn. And then lastly, the building, of course, this is coming from the title as well as like other parts of the context of the table. So phrasal verb. So once you have that covers the simple top K view, and for the selective top K view, the idea is that not only you need to have the tallest building, but you also need to connect that to the categorical attribute value. So in this case, turns out it's a very interesting problem in a natural language, because to understand that, you should say in Shanghai Tower is the tallest building of China, with China, in China, right? So identify in is the right phrasal verb to be used in this context. It's a very interesting natural language problem that we're trying to solve here. All right. Hopefully, I give you some idea of how complicated this is. Distribution over again. Here you actually need to understand like the count basically. Okay, I'm interested in China as the category, and how many total buildings there are, and how many Chinese buildings there are, and you have to identify that. All right. All right. So so far I've told you like all the challenges and interesting problems in this space, and exactly what exact the problem we're trying to do. So we are actually taking a learning-based approach. So we basically try to learn, what we are trying to learn is based on the examples we've seen. I will show you how we generate the training data. We learn the proper sentences that like a human can easily understand. It reads naturally, it's very readable, and it's very interesting for the people to read. All right, so this is the training data, and we basically collected 350 most popular superlative table, Wikipedia tables. Then we did all our work in terms of subject column detection and the metrics and the categorical. And then what we did is we generated very crude templates, right, based on the article or based on the table title and the entity as well as the metric column names. And those crude templates are then sent to our expert raters. The expert rater will actually tell us how those crude templates should be transformed into a very readable one, all right? And then it's actually not easy work. And sometimes it will take like half a minute. Sometimes it will take 10 minutes because the templates are a little bit complicated and the reader have to really look at it. So we spend about 80 person hours in total. And that generates our training data, yielded about 1,000 training example, which is relatively small. But remember, when we are applying the machine learning model, we're actually using a lot of pre-training embeddings already. So a lot of the semantics are encoded in the dimensions that we have, all right? So, and then we have two components we're trying to do the machine learning task on. One is so-called predicting the superlative plus the class component. And for example, here, the table 14ers of the United States, so you will never know, like this is talking about the mountains, therefore the word should be highest, and that's inferred by our model, right? And the cities and towns in Iceland, and it turns out it's ordered according to the population column, therefore the ranking attribute is the most popular one, right? So these are kind of really good results coming from this. Similar thing, phrasal verb, and I'm gonna, in the interest of time, I'm gonna just skip over there. All right, so dynamic maintenance, like the problem here, as I mentioned, is basically trying to remember like the machine learning component and all the human evaluation work are pretty costly. You don't want to redo that anytime a table changes slightly, right? So that's not going to be efficient for you, and it's not going to be maintainable. And so what we are trying to do is basically to track from snapshot to snapshot which table in the current snapshot is actually the semantic continuation of the previous table that we already know, we already generate those interesting fun facts for, right? So this is the overall idea. Like, we want to be able to handle content, small content update, including simple row insertion and deletion, and want to handle schema update as well as a human error occasionally. So here's one example where you see like this is the prior table. And this whole table got moved and converted into something like this. And we want to still be able to capture that, hey, this is the same table we are talking about before, all right? So in the interest of time, I'm not going to get into this part. This is basically the algorithm. It details is in the paper how we actually use a subject column as the anchor and then map to the other columns for the matching purpose, right? Okay. We do some spam protection as well. Just show you some evaluation because I really want to get into the slides because this is the comparison we did in order to get launch approval, meaning like we worked with the product team, use a pool of raters that we have no idea who they are, and a single rater can only do 3 tasks at most. So it's like a very representative of normal users' behavior and perception of the results. So as you can see, we compare with a number of results, earlier results, and we, in terms of interestingness, according to the rater the users giving us, we significantly beat them by orders of magnitude. For this particular one, trivia quiz, I think the reason we don't have one is because they didn't release the code, so we couldn't reproduce their results. And the data set they released only overlap with our data, like a very small percentage, so we couldn't get a reliable number. But as you can see, like basically our performance is like many times like 40, 70 times better than others. All right, cool. All right, so in terms of the 2 components, we also have accuracy That is way above the baselines that we have, so it's pretty good. Table tracking, one thing I want to point out, this has been now more than 9 months, and in the first year we have this launched, only 2% of the tables where the changes required a little bit of human intervention, so there's really minimum burden on us. All right. Conclusion, yeah, so turns out we took a very different view of the fun facts generation problem, because the previous view, people were basically looking at the sentences and trying to summarize the sentences. And they were taking a very entity-centric view. For this entity, what can I find? So our view is very different. Our view is like, hey, here's a very interesting table, and what can we say from this table? So that actually is one of the fundamental changes, and that's what led us to a much better coverage and much more interestingness compared with the previous approaches, either in the literature or inside the Google production system. And we have a very nice table tracking algorithm to make sure that engineers don't have to spend too much time just modifying the templates and things like that. Users love it, and that's why it's launched. And in the future, we're also looking at non-Wikipedia tables and non-superlative tables. This is a little bit more challenging because Wikipedia superlative table is part of, we've been working on table corpus for a while. This is the highest quality of table corpus that you can get. So it really makes our job a lot easier. Once you go beyond those, it's becoming a little bit tricky. So we are looking at those as well. All right. Yeah, questions?